Point 4, quiz explanation part 2. Another 3 questions. Question number 4, 5, and 6. Yeah. Question number 4, given a polynomial with 10 terms. What are those 10 terms? We don't know. We only know there are 10 terms. We use the Horner's rule to evaluate at least how many multiplications do we need. Yeah. All right. Yeah, because here, here I give you the current situation is we need to use Horner's rule, not other ways, because we know there are other ways that can evaluate some special cases. But here I talk about Horner's rule. Yeah, relatively more general cases. Yeah. So don't try to use other special techniques like repeated squaring and repeated cubing. Those two only work for special cases, right? Yeah. At least how many? Here, 10 terms. If we write the polynomial in this way, 10 consecutive terms, 10 consecutive terms, the last one, a 9, x to the 9th, 10 consecutive terms. In this way, we need a minimum number of multiplications, because in this way, the leading term has the minimum degree, right? Degree. All right, think about it. You can write different polynomials with 10 terms if it's not 10 consecutive terms. So the terms you can jump, right? You can jump 1, 4, 7, 9, 12. You can jump 10 terms. Then you will get a higher degree if you apply the Horner's rule. That means you need to have more multiplications. Yeah. Only this case, we have the minimum degree that corresponds to the minimum number of multiplications. So the answer is 9. Right? The answer is 9. Yeah, the same as the degree number. Do not put 10. Yeah. I hope none of you put a 10. Yeah. So 10 minus 1. 10 minus 1. All right. Yeah. Next question, number 5. This one, that's pretty easy, right? Yeah, because here the monomial we are given exponent number power of 2. 2 to the 4th. 2 to the 4th. So then power of 2, that means we should use the repeated squaring technique. Repeated squaring technique, right? 2 to the 4th, that corresponds to 4 multiplications, right? Square, you need a 1, right? Yeah, so you can write it. The first multiplication, when we calculate square, square of square, second multiplication, x to the 4th. Third multiplication, x to the 8th. Third multiplication. And the last multiplication, another square, right? Yeah. We do square operations 4 times. 4 times. Yeah. So the answer is 4. All right. Question number 5. Question number 6. This one probably the hardest question in this quiz. Yeah. Answer is 7. The answer is 7. But many of you probably put 8, answer 8. Why it's 7, not 8? For 8, if you use the repeated squaring, everywhere, then you will get 8. Not the best solution, right? Yeah, because 51 equals 32. Power of 2 plus what? What? 19, right? Yeah, 19. 19, you may write it as 19 equals 16 plus 3, right? Plus 2 plus 1. Okay. All right, so now to get x to the 32nd power, you need a 5 multiplication, right? Yeah. But when you get this number, at the same time you get each term already. So then you just need to do multiplication 1, 2, 3. So 5 plus 3, you get 8. Yeah. Here you use repeated squaring everywhere. That's the reason you do not get the best solution. All right, so now here, because this 51 is a special number. 51 is multiple of 3. Can you see that? 51 equals 3 times 17. If you can see that, then you're almost there. Yeah. So let's look at x to the 51st power equals x to the 17th multiply itself. That's the cubing operation. 3 times. Yeah, multiply itself, Yeah. But you only need to calculate 1 x to the 17th because you can use this value repeatedly. All right. How many? Because it equals x to the 16th multiply 1x, right? X to the 16th, we know we need a 4 multiplication, right? Yeah, 4 multiplication. 2 to the 4th. Add this one. So this term, single term, we need a 5 multiplication. Then we have 2 more. 1 here, 1 here. 5 plus 2, we get 7. How about that? We can do better. Yeah. So here, if we can mix repeated squaring with repeated cubing, then we can get a better solution. All right? Yeah. So that's the best solution for this question. All right, so let's finish our part 2 of quiz 1, question explanation.